Hello, everybody. Okay, so this is for my XP. Sorry, I did Module 3, Chapter 6, Exercise 1, and it was denoted to draw your estimation of what each scatter plot might reasonably look like. So let me read it. Association. Suppose you were to collect data from each pair of variables. You want to make a scatter plot. Which variable would you use as the explanatory variable and which as the response variable? Why? What would you expect to see in the scatter plot? Discuss the likely direction, form, and strength. Okay, so, of course, I defined the definition of explanatory and response variable, because how can we answer that without knowing? This is found on page 184 in your book. So here's what it says. In a scatter plot, you must choose a role for each variable. Assign the y-axis, the response variable, that you hope to predict or explain. Assign the x-axis, the explanatory or predictor variable that accounts for, explains, predicts, or is otherwise responsible for the y variable. It's kind of easy to think of response and explanatory as independent and dependent. The explanatory is kind of, explanatory is kind of the dependent one, like it explains what happens in result to the response. Okay, so let me read all of these. So for A, apples, weight in grams and weight in ounces. To me, I think this was a trick question because in weight, it's going to be the same no matter if it's in grams or ounces. If it weighs something in grams, it's going to weigh the same in ounces. It's just the conversion factor. So there's going to be no correlation. So what I said, there's going to be no correlation. And let me show you the graph now. And so for A, I couldn't even put the explanatory or response because in ounces and weight in grams and ounces is just the same thing. So I said this one would have nothing going on. Weight in grams is the same in ounces. Whatever an apple weighs in grams, it will weigh the same just in ounces with the correct conversion. So I would say there's no response or explanatory variable. It can't make a scatter plot. Okay, I hope that makes sense. So for B, apples, circumference in inches and weight in ounces. I said the response variable would be the circumference because weight depends on the size. So the weight will be the explanatory variable. It explains why the apple weighs more the bigger it gets, if that makes sense. So the response variable would be circumference. So for B, the response variable would be the inches, and circumference, and the explanatory would be the ounces and weight because the weight is gonna, so the weight depends on the size. So basically, weight is the explanatory variable, and the weight kind of explains why the size is so big. So basically what I did for a correlation, for a strength, it would have positive strength because for inches, the bigger it gets, the bigger the ounces are going to get. So the bigger the apple gets, the more it's going to weigh. That makes a lot of sense. So I said there's going to be a strong correlation, and it's going to be positive because it's going up. So if you see, it's a small ounce, but it's going to be a small apple, but up here it's going to be high in ounces and high in inches. So there's a positive correlation. So it's going to be a high strength and, positive, and the form would be very close to each other, be probably close to 1 of correlation. Okay, for C, college freshman, shoe size, grade point average. So for C, I said the response variable would be the grade point average because we want to see if the shoe size affects the grades. So the shoe size would be the explanatory variable. So for C, shoe size will be here because the shoe size is going to explain, the shoe size will explain the grades because the shoe size, I said, is the explanatory. So the shoe size is going to kind of predict on what the grades. For this one, it's very hard to have any kind of shape. There could be any outliers. You could have somebody with a huge shoe size with small grades or somebody with small shoe size, big grades. So I kind of didn't have a good correlation. I kind of drew one with kind of like a 0 correlation just because it's hard for me to know without actual data if grades are affected by shoe size. So for this one, I basically, for the direction, there's kind of no direction. Form, there's kind of no direction and no strength. It's just kind of there. Because for me, I just really don't know if the shoe size is going to affect the grades unless if I had data. If in case I had data and shoe size did affect grades, meaning the bigger the shoe size got, the better the grades were, then this would be a positive correlation and a strong one. But if it's at opposite, it could be negative. But for this one, again, for strength, there's just no strength and no shape because I have no actual data. Okay, for D, gasoline. Number of miles you drove since filling up and then gallons remaining in your tank. I said, since you want to ultimately know the remaining gallons in your tank based on the miles you've driven, the explanatory variable would be the remaining gallons in your tank, and the number of miles you have driven is the response for the y variable. So that's the response variable. So the number of miles will affect the amount of gas remaining. So the number of miles driven is the explanatory. So as you can see, number of miles driven is going to explain how much gallons are remaining. That makes sense. Because the more miles we're going to drive, the less gallons are remaining. So for me, I did actually a negative correlation, but it's a very strong correlation, but it's just negative because you can tell. So say here there's a the more miles driven, the less gallons remain. So here, not a lot of miles are driven, but there's a lot of gallons remaining. Whereas here, a lot of miles are driven and there's not a lot of gallons remaining. I mean, this makes sense if we think of our car. The more miles we drive, the less gas we're going to have in our tank. That's just how a car works. So basically, the number of miles driven is going to explain. That's going to be the explaining reason of how many gallons remaining. So the number of miles, again, driven is going to explain the amount of gallons remaining. And in this case, I did a negative slope going down just because it's going down. The more miles driven, the less gallons remaining. So that makes sense. Why it's different than B is B, the more the apple, the bigger the apple, the more it's going to weigh. So it all just depends. You have to read the context of what you are given. Always remember that the response variable is the predictor, the explainer, and the explanatory, it accounts for, it explains why, it accounts for the explaining, the prediction, or otherwise response to the y variable. Just remember that. Everything changes all again based on what you're looking at. Just look and see if the two would have a correlation and would not, and if you could say they wouldn't have a correlation but still do, then it's not going to be like a very strong correlation, and there's not going to be a strong strength, strong form, direction, anything. So let me know if all of this makes sense. Thank you.